Hopefully this works. It's been a few weeks. I'm still getting everything settled, but we'll get things going. Hello, hello. Let me know how it's going. Restream chat. Move down here. Hopefully the audio's okay. There's some sirens right now, but it should be pretty quiet still. And I'm also like, my window is up above a fire extinguisher place, and they like vented out the top some too. Jeff hears me, great, thank you. Hello, DCD. Let me shrink down my private YouTube. I think we're going. I think I did everything on my list. I updated the titles, which is what I sometimes forget. This is not John Park's workshop. This is Deep Dive with Scott. So I guess we'll get going, although I don't have it quite the way I normally do. Just put this here. That'll work. All right, so let me say hellos and then we'll get started. So hello, Jeff. Hello, Todd. Audio sounds good. Video looks good. Great. Dexter, hello. Snowy afternoon in the Beehive state. Tim did a great job. Yeah, great. That's a great segue. Oh, hello, Beata and Dave as well. First and foremost, a huge thank you to Tim, aka Foamy Guy, who has really held down the deep dive fort for me when I've been unable to stream, both when I was on paternity leave with the first kiddo and also in the last few weeks. And I'll let you know what's been going on. But first, let me introduce, in case folks don't know, hello, Darwin and Ushash. Welcome. So my name is Scott. I work for Adafruit. Adafruit is an open source hardware and software company based out of New York City. I work remotely for them, so I'm actually in Seattle. So probably by the time the stream is done, about 2 hours maybe, as long as my voice holds up. It'll be a lot darker probably, because we're in the really gets dark really early period here in Seattle. And what I do for Adafruit is I work on CircuitPython. So CircuitPython is also open source. It's a firmware or a piece of software that runs on little tiny computers called microcontrollers. And I always, when I say that, I always look at my desk and see what I have. So here's an ESP32S3. It's got a lid on it. So there's a smaller chip in there that is basically a full computer. And this is a sneak peek. This is a prototype camera board, which I'm holding my finger over the camera here, I think. No, the camera's here. Sorry, I haven't actually used it yet. I have it for testing, but I haven't tested it yet. Yeah, I think the sunset, let me see, my phone has a sunset time on it. Sunset is at 4:19 Pacific time tonight. And we've got about 3 weeks until that starts to turn around and it gets lighter again. So yeah, it's pretty rough. Pretty rough. Although this is probably the first time in my life I've appreciated having it lighter early in the morning, because that's great, not John Park's workshop. Because I have a little one. I have a 1-year-old, and he likes to get up about like 6:30, 7 o'clock. So having it lighter in the morning is somewhat nicer. Before I had a kid, I would just sleep through it. And I was like, why? I don't care. Anyway, so yeah, thanks again to Tim, who's been covering for me the last few weeks. And we'll probably cover, again, kind of going through the holidays. Usually I'm out in the holidays anyway, so that's no surprise. But I wanted to stream this week because I kind of knew I would be able to. Or at least I had a very... Oh, Jeff, I'm sorry to hear that. Used to love Pacific Standard Time, but not since losing my spouse. Being sad is not why I'm here. I got a little bad news for you, because I have something sad to talk about that I just wanted to let everybody know. It does look like I'm clipping on the OBS side, so hopefully I just moved it down a little bit. So hopefully that'll be better, Todd. So the sad bit and the reason that I've been out is that my mom got diagnosed with terminal cancer, basically like late stage pancreatic cancer, which I did not know. I didn't fully appreciate how bad that is. So she's still alive, which is good. So she got diagnosed at the start of November and was in the hospital and then in hospice, and actually didn't. She thought once she left the hospital she would degrade, and that's why she went to hospice. But then she was at my house for a week over Thanksgiving, which was amazing. Had lots of time with my family, with my mom and my dad. And then I have a sister and her kids, and they were sick. So my mom actually is at home now, which is great. She got to go home, which she didn't think she was going to be able to do, and see a bunch of friends there as well. So that's why I've been out, is because of like I am in this mode of like, I don't know, like I'm going to spend a bunch of time with my mom, not absolutely every waking minute. Obviously, that's why I'm here. But it is a big unknown kind of how she'll be feeling in the next weeks or maybe months. So that's definitely my priority, and you know, Adafruit and Phil and Lamore have been super supportive, and everybody at Adafruit and in our CircuitPython community is super supportive. So if you want to help keep that good thing going, you can always support me and Adafruit through adafruit.com. But I know that's a little bit of a thing. Yeah, thank you. It's been, November was really rough. She was in the hospital for like 2 weeks, and then hospice for a week, and then my house for a week. But it's been really nice to spend a lot of time with them, so that's been good. Yeah, so thanks again to Tim for, you know, and Adafruit in general for giving me the space as I've needed it, as our family's grown, and as going through this. Grab that with both hands, yeah, totally. Jeff says, I wish I could tell you it'll be okay, but it's harder than I could ever imagined. Oh yeah, I understand that. I understand that I'm still in the start of it, for sure. Yeah, but I know we'll get through it. That doesn't mean it won't be hard, but I'll survive. So yeah, lesson is spend time with your family. Tell them you love them, because you never know. I'm lucky enough that we know ahead of time, so we can spend lots of good time together first. Okay, I think that's enough of the sad part. Sorry, Jeff. I have been, so this week I actually worked more than I've worked in a fair number of weeks, I think. Went and saw my family on Wednesday, so I was out Wednesday, but worked Monday, Tuesday, and yesterday and today. Which is great because I like my work. So yeah, we'll see what next week brings. Deep dives will be kind of like as things happen, we'll see. And I'll work with Tim on that as well. He's super flexible. So expect to see Tim on deep dives some more. He does really awesome work. He's been working on circup, which it took me a really long time to kind of get on the circup train. So if you don't know, circup is a Python command line program that runs from your computer and can be used to automatically update libraries on your CircuitPython devices. And it took me a really long time to get on board with that, but I've started using it. It's really nice. It's really nice, like copy a code.py over, and then you just say, or you can do like circup install. It's kind of like pip. Like the CPython corollary is pip, but circup is great too. So Tim was working on adding web workflow support to circup so that you could use circup talking over the Wi-Fi network to a CircuitPython device, which is going to be super handy as well. And so that's what I was doing earlier in the week. One thing that Lamore and I had on our radar to work on is improvements to the web workflow. Yeah, hats off to Adafruit for their unsurprising compassion and empathy. Yeah, they've been great. I really I got so lucky with this job. Like the timing was perfect, the topic was perfect. It just worked. It's worked out so well. So yeah, very lucky. Not everybody's that lucky. But I do now pay into, like, Washington State, which is the state I live in, has a paid family leave program. And as I'm technically self-employed, so Adafruit contracts my company to do all the work that you see. And so when we were expecting our first kid, I opted into the paid leave. And now that paid leave, it's a great program because it gives everybody in Washington State that flexibility of, like, if you need to take time for caregiving or you need to take time for having a child, like that's a cool program. And as a self-employed person, you opt in. So I've opted into that, which has been great. Yeah, so one thing that was on the radar was spending some time improving web workflow. Lady Ada had designed a board to go into that, like, children's toy. And she was hoping or thinking that it would be the first kind of product where the expectation is that you're only communicating to it wirelessly. So she was really spending some time with, sorry, I just looked at a list of files on a random SD card and thought, is there anything on there that I shouldn't show? But I don't think there is. I saw this, like, shop nearby online, which was like a project I did like briefly during the pandemic, which is why it triggered my brain. So she was doing web workflow for this playback PCB, and she found some issues with it, including reliability. So one of the issues that Melissa had filed after working with Lamore had to do with reliability of uploading large files. And so some of the work I did this week, we all know, if you don't know, deep dives include tangents. And I didn't say this actually, I don't think. If you want to take me on a tangent, you have questions that you think I could, if you have questions you think I could answer, then let me go ahead and ask them. I'm happy to wander. Hopefully that's charming and not annoying. I think the benefit of deep dives is that you get to see every single step because I do it raw and unedited. So put on your snorkel and dive with me. And now I lost my train of thought. Anyway, I was working on web workflow. So I did a few changes, and maybe we'll switch to the desktop here. And no, I don't think my finances are here. Although I do have a project that is finance related. Web workflow. Thank you, David. Very surprising things on those thumb drives. Oh, yeah. Yes. Okay. So let's switch to the desktop before I forget. And I'll scooch this one out of the way. We have a lot to talk about. I'm going to wander. I got a new laptop. We could unbox some boxes because it's been sitting over there and I haven't done it. But we won't do that. We'll resist the urge, at least for a little while. So there's a couple fixes I did on the web workflow. So it's not in the latest alpha yet. But if you do use web workflow, it'd be great if you could use absolute newest. And I think we'll probably have another alpha release next week, or maybe even a beta. So CircuitPython 9 is the next major version of CircuitPython that we're going to release. And I was talking with Dan and Jeff and and we kind of like had the feeling that it's time to, we were in this mode of like changing everything and adding stuff. And both Dan and Jeff thought it was more time to like strip down and move to this like bug fixing mode so that we can get 9.0 stable. We have 8.2.8 already, and that is our current stable release, but we're gonna have the next adabox. I won't tell you. people don't know what adabox is. Sorry, don't let me spoil it. Anyway, for the next one, we'll likely need, people will want to use 9. And so getting 9.0 stable is going to kind of be the next thing for us to do. And working on smaller tractable issues is like totally a better thing for me to be working on right now, because I don't know what my schedule is. And my brain is not like, my brain can't take on 2 weeks of like solid work on a topic right now. So it's a good time for us to pivot kind of into bug fixing mode. And I think we'll call those betas, and then like when we don't think we have any more bugs, we'll do a release candidate, and that's when it's pretty much done. So we did a pass through the bugs today, and we had 40 bugs left to go over. So hopefully we'll get through those pretty quick and get a release candidate out, which will be awesome. Anyway, so back to the tangent. Sometimes I think of it as popping off the stack. So PRs I did this week was mainly 2 fixes. One was just web workflow improvements, and there's a bunch of different things there. So when you close a socket, there's not really a way to say flush, like don't close until you're done. But there is an option that you can set to basically say don't queue the next thing that I give you. So I did a lot of work in the web workflow to designate kind of like the last bit of a string that we send out, so that it hopefully flushes like error responses in particular before closing the socket. What I was seeing is that like some stuff was getting an error response, but you'd only get part of the error response. So that was one thing I did. This was all around lost Twitch. Okay. Let me just take a peek at Restream. Restream is going. It looks okay. Destinations, let me see. It looks okay on the Restream side. Perfect. Okay. Thanks for letting me know, Tyeth. I can take a peek. I have it open, and I have a second browser kind of under here that I can check it at. So I was debugging uploading files that were too large, because that's pretty concrete, sort of like, let's make this work better. And I saw the partial error responses, and I also realized that, so what it does is it knows how big the file is up front. It tries to take, if the file exists, it tries to seek to the largest thing, which actually will tell you whether there's enough room or not. So that kind of like sets the file size the appropriate size, and then you seek back to where you want to write files as it comes in. But if it's too big, we were seeking as far as we could, but not all the way. And I wasn't resetting it back to the old state of the file, so I did that. Also, if the web browser uses a put call, and so it sends the whole file. So you'll see this is kind of unfortunate, but basically, even if when you on the web browser try to upload a file that's too big, it takes a long time to know it's too big, because the device still has to read all of the data and just throw it away, unfortunately. There is a part of the HTTP protocol that curl will do that says like, hey, this is how much data I'm going to send you. Is that okay? And you can escape earlier, but browsers don't do that. So if you upload a large file that won't fit, it will still take time to discard, but it should work correctly. And I got it to the point where the browser did get the response correctly, which it wasn't doing before this. I bumped the API version number to 3 because I changed, I think Foamy Guy added this. There's a disk info.json file you can request from CircuitPython. It tells you how much disk you've used and how much you have free. And I made that a list because one of the other items on the web workflow to-do list was to support accessing SD cards from the web workflow. So that if you had a large file, like an audio file in the toy case, like you could use web workflow to upload a large file directly to an SD card. And that is something that I'm still kind of working on. So preemptively, I changed diskinfo.json to a list instead of a single object, but it only returns one item right now. I have a work in progress branch that is trying to get SD cards working, but it doesn't work yet. That's one thing I did, and then the other quick thing I did is there was also a bug from Melissa about if you do a very simple while loop, like a while true print sleep, and then do Control C, it doesn't work. And this is something that used to work in early 8.0 and then broke along the way. And I figured out what broke it. There was some reliability changes that someone else actually made the web workflow that had broken this. And so this is a simple fix to make sure that we call the WebSocket background stuff every time. So hopefully that'll work better as well. And then yesterday I was working on the SD card stuff that we might get to today, but I'm not actually sure. There's a couple of different code ways we could go. And also if people have questions, just ask. I'm happy to wander in any direction you're curious about. But there is a little bit of other exciting news, which was surprising. One of the things that we did in CircuitPython 9 is we updated from the ESP IDF 4 to version 5. And version 5, or the IDF is like the vendor-provided software for the Espressif chips. And we had updated already to 5.1, which is like kind of the latest. But since we did that, they released a minor version of 5.1. So they've released, 2 weeks ago, they released 5.1.2. And so and the thing that I kind of want to finish is a pull request that is updating CircuitPython main to 5.1.2, hoping that maybe there's some latent bugs that people have found indirectly through CircuitPython that just magically get fixed. And it's kind of nice, like we're still relatively early in like the stabilization process, and also updating minor versions of the IDF really shouldn't be too destabilizing. So I'm working on that. I just started working on it. Unfortunately, there's some changes that are taking more code or like flash size space. So that's what I've got to work on. The exciting part about this though is leave it to Dan to say like, let's read the release notes for it. So in the release notes, which are here, I was just like tooling it around, like, okay, these are thread changes. We don't have thread support yet. Zigbee, so thread is the thing that underpins the Matter spec. I love but also fear when bugs get fixed automatically. Yeah, it's true. A lot of the bugs that we went through today were just like, some of them were really old, like 8.0 bugs. And we just had to say, like, we need to retest this. We have a label for issues that just say needs retest. And actually, if folks are looking to help, that's a great way. You could look at, say, what needs retest and see if you have the board and just try to reproduce it again. Because, like, more than half the battle, I think, of issues and bugs is just being able to reproduce it. Once you can reproduce it, they're usually not too hard to fix. Anyway, so I was looking through these release notes and I saw, let's see. So this is a lot of like C2, C6, H2 support, which we support now, but we don't really have any devices that use it. Like we have a C3 QT Py, but that's pretty much it. This is controller side, but then there's also Blue Droid host, NimBLE host, and somehow I saw this, there's this thing here that says added support for dynamic services addition and deletion. And I just went, I did not know this was coming, but this is the thing that has been holding up BLE support on the ESP. For those of you who have wanted BLE on ESP, this is the functionality that really hung me up when I was trying to add it. Because the way that we do BLE, I kind of assumed BLE would work, was that Calblades asks, is this video about debugging for a Raspberry Pi? This is more debugging on a microcontroller level. If you're talking about Raspberry Pi single board computers, generally right now we're talking about expressive microcontrollers, so ESP32 chips. And we're probably going to end up just debugging like code size issues. There's the exclamation points. Yeah, so Dexter and Toddbot say this is pretty great for BLE. Yes, so the way that we assumed BLE worked in the way CircuitPython uses it is that we'll start it up before user code runs. We'll start it up before user code runs, and then we'll add the BLE workflow services or servers, start those up so that you can get access to like the REPL and the file stuff. And then user code runs. And once user code runs, it can add additional services to it that if you want to make those more services available. Now, this wasn't supported when I went to add BLE support to ESP. So I didn't realize that immediately. So that's why you see part of that support in Expressive already. Because like I realized this and I was like, and we kind of said like, well, like there are some uses where you don't need to create a service, you just want to talk to another one. And so we kind of like, and Dan just fixed it. So anyway, this is the thing that was blocking, like that really took the wind out of the BLE sales on ESP. So I was super duper excited. I just saw it a couple hours ago that they had added this this support. So we have this issue here. It's 5926, and that's the tracking issue for getting full BLE support in the Expressive port. So if you want to follow along, if that's exciting to you and you want to see when it's fixed, this is the place to do it. Now, I don't think I was tempted to jump right on it, but the problem is that although that support in the IDF was blocking the work that we were going to do for BLE, there is more work on top of that to do on the CircuitPython side. Specifically bonding, which is like the encryption, encrypted like communications channels stuff, wasn't done either. So there is like, it's not a small piece of work to do. What is the meaning / history behind NimBLE? I don't know. It comes out of the mynewt project, which is pretty defunct, in my opinion. Mynewt has kind of had their lunch eaten by Zephyr. There was a point where it was like unclear which way people were going to go. And basically, I forget who, I think it was Nordic actually. Nordic kind of like just decided to go the Zephyr route, and that really put the, I'm using this analogy again, but really put the wind behind the Zephyr sales when Nordic decided to switch to it. They do a ton, Nordic does a ton of work with Zephyr. So I don't know the background of NimBLE. I don't know why it's named that. But I like it because like my criticism of Zephyr, and this is deliberate on their part, is they're trying to be a very monolithic project, basically like everything in all in one thing. Whereas because CircuitPython is kind of its own monolithic thing, it's really hard to integrate the two. What we'd rather do is use something like NimBLE, which is like a more standalone BLE stack in CircuitPython. So we had hoped at one point that we would actually be able to just use NimBLE for all of our BLE, including the NRFs. which maybe we can. I'm not sure. I don't actually know release notes. I don't know if the NimBLE dynamic services is actually for upstream NimBLE. Host API additions. See, I think the dynamic services thing might be specific to ESP NimBLE, so they have their own forked version of NimBLE. It's quite dead. Yeah, when I see release notes that mention NimBLE, I mean, I also know that like I know that the Espressif, like it's under the BLE larger header. But then I also know that like they have two BLE stacks in the IDF. One is NimBLE and one is BlueDroid. So I already have that background, so when I'm looking for it. Okay, Dave asked a question that I'm not really the person to answer. Says, would Adafruit Industries ever design and have their own MCU manufactured? I doubt it. I think, you know, Adafruit can play the role of influencing them more than, doesn't really, like Adafruit itself doesn't have the expertise to do it. Like you see Raspberry Pi, you know, they were doing single board computers and they still are, but like their background is in chip design. Like a bunch of those folks at Raspberry Pi Trading, like they used to work on chips for Broadcom. And then like, which is I think what Eben did. And then he knew that these chips had these like ARM cores on the side, and then he could make these single board computers out of it. So they're really just kind of getting back to their bread and butter, which is chip design. And the RP2040 is a great chip. So they have a first good showing. Adafruit doesn't have that history, right? Like nobody at Adafruit has chip design background. So I don't think you'd ever see that. Like I personally am interested in like system on a chip design, particularly for FPGAs, but that's not a reason to like make your own chip. Especially when the chips that are out there are great, or like there's lots of good chips to build upon. And the other thing is that you really need scale to make them economical, which is a challenge in and of itself. I think largely Adafruit scale does not compare to like, I'm going to make a microcontroller that goes in all cars, or you know, every iPhone or things like that. So it's not really my position to say whether Adafruit will, but I would bet against it for sure. Although I do have opinions because I work with a lot of different microcontrollers, so I definitely feel like, you know, it's great to be able to, if we can influence it, then that would be cool. And I do follow, Jeff says it's super expensive to design your own sock. Yeah, the Open FPGA community is the one that I kind of lurk in, and they're doing some really cool stuff around chip, like ASIC design as well. So Tiny Tape Out is really cool, where it's kind of like OshPark for chip designs, where it's like 100 different designs all kind of muxed together in one chip. So you produce one chip, but you get a bunch of designs out of it, which I think is really neat. So yeah, I'm interested in it, but I don't think it makes any. My personal opinion is it makes no sense for Adafruit to get into that business. For sure, it's a whole different set of skills. Okay, well that BLE stuff is really exciting, but I'm not going to work on it. I'm going to work on something that is a prerequisite for it. So I've made this pull request here, which is to update our copy of the IDF to 5.1.2. And it's pretty simple. I made a new branch on our fork version of the IDF, which updates a bunch of files. And then I also now have one config setting set to it. I love the idea of sock design. Like I was telling somebody, I was like, you know, I have a Google Doc somewhere of just like, why doesn't it do this or why doesn't it do that? One thing I was talking about is like there should be a bit in a peripherals register space that tells you whether the clock is running, so that because there's usually a clock peripheral that controls the clock signals to all the other peripherals. Like it would be nice to know if you managed to route a clock to the right place. So I do have kind of like a wish list of things, but that doesn't mean that I need to make my own to see those come to fruition. I think a lot of Adafruit's role in the industry is like trend setting and kind of setting requirements as well. And there potentially is a lot of power in that as well. Of like going to manufacturers and saying like, hey, like for CircuitPython, we really want to do dual USB so that we can do one device and one host or like things like that. Purchase off-the-shelf products if they're available. Yeah. Yeah, and like I even came to the same conclusion. I had one idea I thought for like making an FPGA more accessible would be to have a Stemma Qt board that was an FPGA that you could load code onto. The mock XOs from Lattice are a great example or a great potential chip for that because they have I2C FPGA loading, but then they're still like not very cheap. And I was thinking like, well, I could actually do the same thing basically, but with a microcontroller for a lot less money. And just, you know, you need another CPU core, you do Stemma Qt to another microcontroller. And then I realized that the STM chips have I2C bootloaders on them. And you can buy STM32G0s for like 50 cents. Like FPGAs are cool, but you really like at the data rates that we're doing for anything CircuitPython, you don't need FPGAs. Like FPGAs are really like data rate heavy stuff. It would be kind of cool to have a Feather or Cutie Pie that was actually an FPGA running some software. So there is a good Feather. If you want to get into this, so a third-party person made a thing called the OrangeCrab. And if I had time, this is what I would do. If I had time, this is what I would work on. So it's a feather shaped. It's a Lattice ECP5, and you can buy 2 different versions with depending on how many like lookup tables you want. It's like $100. It's not cheap, but it's also not that expensive. 120 or 180. So it's gone up a little bit, but they're available, which is great. And these ECP5s are supported with the Open Toolchain. So yeah, if you want a Feather that runs that is an FPGA, this is the one I recommend. But there's a lot on the software side that I would like to do, and that's the rabbit hole I'm trying to stay out of. No, Scott, you need to get hardware threading in CircuitPython, right? I mean, the future will probably be more cores, no. I think that is in our future, but not anytime soon. Meaning, I think at some point we'll want to move CircuitPython on top of an RTOS that can manage multiple threads of execution across multiple cores. But, you know, like the Raspberry Pis, like we actually support the Broadcom chips and they have multiple core, like 4 cores. But anything else we have at most dual core. So the S3, ESP32S3 is dual core, and the RP2040 is dual core. And like, we really don't need to run user code on 2 cores. So on the ESP side, there's free RTOS that the IDF uses. and it just runs all the networking stuff, or most of the networking stuff on the other core, and that's fine. That's totally fine, and it does actually help speed. If you do comparisons between the S2 and the S3, like getting all the networking stuff on a second core does help you on the speed of CircuitPython. And then like on the RP2040, like we heard people at the launch being like, but there's 2 cores, I want access to them. And only recently have we like started using the second core for USB host, for the DVI output, and like having that as a resource for us to use internally has been really beneficial. Dexter says, my RP2040 system has 6 cores. Yeah, so I wouldn't be surprised if we got there, but there's other things that we can use those cores for on the behalf of the user, not directly for user code. PIO on the RP2040 has been much more my speed lately. Nice bite-sized programmable logic. Yeah, totally. I think I still do like this idea of like a STEMMA QT that has a separate ARM core, right? Like, yeah, and there was actually an interesting, I subscribed to, we lurk on the MicroPython side of things, and somebody is working on OpenAMP support, I think is what it's called. So there's this pending PR on the MicroPython side. OpenAMP is open, I believe, asymmetric multiprocessing. So it's like some sort of like standard for running, like managing code on another core, I think. So I'm subscribed to this just because it's like interesting. So instead of like CircuitPython running user code on multiple cores, it's more like using CircuitPython as the thing that's managing multiple cores, like code running on other cores. So like it's loading ELF files, so it's really low level, but it's kind of interesting to me. Okay, any other questions before I try to fix? So this PR is a prerequisite for the BLE stuff. But even though I was hoping to fix the code size issue, so when I change the IDF, it reruns everything, and there's some builds that are too big. So, although this is interesting because this is an N32. Huh. Okay, so this is a different problem. Well, that's interesting. So we'll fix that too. We'll see if we can reproduce that locally, and then I was sort of looking at JP's issues with display interfering with sound, whereas if I could get the display code on the other core while SynthIO was running on the other core, it might have mitigated the issue. Yes, so that is totally within the realm of what we could do. And that, to me, is like CircuitPython using the second core. It's not using it for user code. I think that's totally cool. We could do that. And that's why I think we do want to move to an RTOS at some point that can help manage that. But there are definitely simpler things you can do. So right now, the way that the displays are updated is that you compute some of the display update, you send the pixels over, and then you go back to computing it. And if we had an asynchronous SPI transmission API, we could actually overlap the computation with the sending, but we don't do that right now. So that's one area where it's like, yeah, 2 cores would be great, but like we could actually change the code and be better off anyway. And then there was also another, I think it was a Todbot issue with the NeoPixels in audio playing, where the NeoPixels were having trouble. And that was a tuning issue with, if you transmit a few NeoPixels, it doesn't use DMA, but then if you do a bunch of neopixels, it does. And if you're not using DMA, there's a loop that fills up the FIFO, and in that loop, we do background tasks. So CircuitPython doesn't use an RTOS internally, but it does have this mechanic of I'm idling, let me run things that I may want to run, which we call background tasks. And that includes filling audio buffers. So if you're outputting neopixels on the RP2040, a few neopixels, you may choose to do some audio work between filling that buffer, which is a bummer. Yeah, or a GPU, another ball of string. So yeah, the higher end IMX RTs have, the thing that you find before a GPU is a 2D DMA for blending stuff together. And we are moving more to that world where CircuitPython has a frame buffer on board for the like qualia stuff. Like those displays have the frame buffer on board, and that changes kind of the dynamic of display I/O some too. But yeah, so those, I would say that's not user code. That's not a user code problem. That's a CircuitPython problem. Like user code can set up all the audio stuff, and just synth.io could run on the second core, and CircuitPython can manage it, and the user doesn't have to do it. I'd much rather have that flexibility. Is the core of CircuitPython modular? I don't know exactly what you mean by modular. There's like a core VM, and then a lot of the like if you import a module in Python, it usually corresponds to like some chunk of C code. But the task stuff is not well structured. It's better structured than it used to be, like the background task stuff is, but it's not an RTOS. It's not threads, not separate stacks and things. Okay, let's see. Let's build this board locally. PIO is a chunk of programmable logic in... Oh. I think DCD knows what PIO is, but he was just asking about how you're counting up to 6. I don't think PIO is used for cap touch. Cap touch tends, like the cap touch where you have the external resistor is just, you read the ADC, you set it high and then measure how long it takes to drain through a high resistor. Oh, meaning you can build a light version. Yeah, so we basically have knobs for building at the module level, and that's one change that we did in CircuitPython 9. Is I actually split out what I call bus display, which is, so there used to be display.io.display, and that was used with like the 4-wire SPI displays. But then there's also I split that out into a bus display module. So basically, we enable and disable things on the Python module level. And the reason to do it at that level is that when you import early usually, and so you get error early as well. And then we also had different implementations for different APIs potentially as well. Touch PIO library uses PIO. Interesting. Oh, see, I didn't clean it first. Let's try it again. So what I'm trying to do is just get it to the point where I can build, or all of the boards build with the new IDF version. And then I was like tempted, like I kind of like, oh, let me turn on this new feature of the BLE stuff. But the reality is that the BLE, when the BLE code is actually finished, it's going to pull in a lot more code, and we're going to have to figure out how to get it to fix, or how to, yeah, we're going to have to decide. So the builds that are usually a problem, and this is not one of them, the troublesome builds are usually the 4 megabyte flash builds, because we do like 1.5 meg of firmware, and we have 2 spots for that for OTA, and then we leave 1 meg for the CircuitPy drive. Good night, Dave. Thanks for hanging out. Sleep tight. So we're gonna have to either decide, like, the trend has been people disabling the dual firmware locations, but if we're moving to this world, which the web workflow work is doing, where we actually do want to like have it well supported that you only connect over Wi-Fi, you're really going to want those two spots so that you can do like actual CircuitPython updates. Without that, you can't actually do CircuitPython updates. So what happened to this? It's in one location. I wonder if this is something that we added. Feel free to ask questions if you have them. I'm just bouncing around. So that's in components, bootloader support, bootloader flash source. I'm thinking this might be a mismerge because I rebased. We have a few changes we did. It might be a rebase problem. Oh, this is ESP NimBLE. Components, bootloader support, bootloader flash, source, bootloader flash config, ESP32S3. So this doesn't look like it's implicit declaration of get spy mode 276. Spy flash octal 32-bit address enable. This probably exists. No? This might just be a problem in the IDF, which probably means that we just want to disable that? Or did they really not test it with? They actually have a branch for 5.2, but it's not been released yet. Components, bootloader support. Fix OTA fail on octal flash. And that sounds like the problem. I bet that's when they introduced it. Ah, but here, it is in there. It is in bootloader flash.c. So why is it not in ours? Or maybe it is. 832. Why are those different? I'm in the .c file. This one's 867 long. Huh. Looks like I need to learn to use the GitHub tools to browse code better. It's gotten immensely better. Like this, when they redid the code search, it's been awesome. I definitely default to browsing code here first. October 23rd. Bootloader Flash. This is completely different. This is on 512. Oh, this is on master. But on 5.1, it's going to be broken. $785. So we are matched up, but I don't see how this will work. This flash mode, yeah, so it bumped me to a different branch, I think. 32-bit address enable. Where do we use that? Kconfig. I don't know why it's enabled. Components by flash Kconfig. Then maybe we'll just have to fix this. Like this is like a missed backport. Getting random texts. So that's in Spy Flash. Oh. Oh. Sorry, I'm getting text messages wraparound telling me I put stuff in our recycling we shouldn't have. Right chunk, override. I'm looking for 32-bit address. Default yes if flash size is, it's invisible for users. Default yes if it's an octal flash and the flash is 32 megs, 64 megs, or 128 megs. I know, it's getting darker, isn't it? The sun is up, it's just behind clouds. I could turn down the lights and I'll make it look a little more natural, maybe. Dim it. Ugh. That one's not responding. Hey, there's an update available. Here, now it's that better? That look less blown out. I have to do that so it's basically like a normal light level in here. Okay, so I don't know. I wonder if there's if somebody's found the bug. This is not our bug. Let's just see if somebody has let them know. Espressif is pretty responsive. No issues, no pull requests. But it's in the like newer versions. I wonder. Oh, my font could be bigger when I'm streaming. Yeah, I don't know. Just tell me. I can make it bigger. I think I did that in previously. So what I was looking at is that there's this setting here of 32-bit address enable, and I'm a little curious what we used to do, because if this is relatively new. So let's go Adafruit ESP IDF, but this time we're going to look at the branch that we're currently using, which is just the 5.1.1. So now if we look at components, maybe let's do bootloader support, bootloader flash, source, S3. Yeah, so it didn't used to have that setting at all. Which is probably why it was probably added because it was a bug, but they didn't fix it correctly. And apparently they didn't test on a 32 meg board. And this board or this module is one that they sell. So it's just a problem up there. And I don't actually know what this bootloader support does thing as well. You know what we can do is we're in release 5.1, we can hit blame. And OTA fail on octal flash with 32 megabytes of memory. So this is what they were trying to fix. Ah. Okay. Flash mode is either fast read or slow read mode. So if we wanted to cheat it, is there any CI on the ESP IDF distribution? Why don't they see the error you see? I assume there is. I'm sure they have lots of testing. They just don't have this testing. Like, I think they have build farms and stuff, like device farms that they run stuff on. They just must not have anything that this applied to. Invalid magic byte. I think the safe thing to do, like the minimal thing we could do is, like, there's these two modes of fast and slow. And I assume that, actually, let's look at Adafruit IDF, ESP NimBLE. This we don't need. But in the expressive stuff in master, in the main branch, we can do components, bootloader support, bootloader flash, source flash. And it was what, 800 something? Ah, there's my morning coffee. I switched back to nights again. Okay, so you're just waking up, Beata? You're getting up with me. Get spy mode. So it's actually reading a register. Its default is fast read. The else condition is slow read. Like, I think slow read's probably a good default. So I think what I can do is, because the problem is that it's missing the function call that finds this thing. And I could basically say, we're just gonna use slow read. And it's only related to the bootloader, like, and so it doesn't really matter. I don't think. Like, we're not doing OTA stuff anyway. This. I bet that'll fix our compilation issue. Magic smoke enabled test. Yeah, they'll probably add a test case once they submit an issue. Anytime I have a problem building the IDF, I always clean. I'm glad I turned the lights down. It looks a little bit better, I think. I could also open the window, like raise the shade. I gotta be very careful, like I zap, scooching around, I zap. If I had a second camera that was like more reliable, and maybe cat cam is working now, but I could do window cam. Let's see. Is it the overhead? No. Is it cats? No. It looks like it's on. I've had so much trouble with this C920 and I don't know why. Anyway, it used to work. The light was on, now it's off. I triggered Alexa. All right, so it looks like we got further in the build. So that's a simple tip. Is if you're having build problems, clean and then build again, and then you'll see. Oh, no, it did fail. It did fail still. Unknown type name. In that function. Oh my goodness. They did not do a great job with this. This is the old version. All right, the other thing I could do is just delete it. So if 0, if false. Actually, if we're going to do that. So this just means OTA is going to be broken on this. But we don't have OTA support anyway. And that's only on the one, like the N32R whatevers. I'm going to clean build again just to be sure. A small humidifier helps with the zap, but with electronics you want to feed it with distilled water. A white coating on all my high voltage things pointed that out. That's a good idea. This says it's 37 degrees, 37% humidity in here, which I didn't think was that low, but I was actually, yeah, like, I've like zapped my USB bus and stuff. It's much more electrostatic in here than it is at my house. It's nice having the shade up. And the sun's going down, and it's 3:15. We do have a humidifier in the kiddo's room right now because he's in the like cold phase. My partner has cold too. I've seemed to skirt it so far. Oh, I call it the biohazard phase because he's in daycare, so he gets all the stuff. This is the window I was like, wait, am I showing something I shouldn't be? Some random SD card. I was working on the SD card over web workflow stuff, but I got distracted. And with the IDF update, that's the sort of thing we definitely want to get into, like early release. Sooner the better we get the IDF update. And it still failed? Bootloader flash. Did this just come in? So I didn't actually update to the release. I updated to the release plus a single. This was committed last month. But is this the one thing that got pulled in? Maybe that's my problem. Like they've done a lot of testing, but I picked up one more commit. No, that's not the commit that I picked up. So I'm here, but I think, well, no. 36623. What version is this set up to? 482. 3 weeks ago. Okay, so I'm still quite ahead of it. 482. Is it even on this page? 482. No. Okay, so I'm like updating. It said 3 weeks ago. It was 482, right? There it is. Okay, so I'm on a bunch of untested stuff. ADC calibration. I assume we're gonna find that other. I'm ahead of the IDF release. So they're working on, 5.1.3. And I'm But there's like fixed BLE bugs. Oh, here it is. OTA fail on Octal Flash 5.1. Okay, maybe the simplest thing is to not go all the way new, because we still do get the. Yeah, maybe the better thing to do is to actually. Okay, let's do that. We'll actually make it 5.1 too. So ESP IDF, git status, git log. So if we look here, we have 4 changes, 5 changes from me, or 4 changes from me, 1 from microdev, and then this shows the branch. And tags would show up as well, but there is not a tag. So I think, I think this is good for security. So we're going to want to update again when they do 5.1.3. But this sort of bug that we're hitting now is like, they should find it before they do a release. So I think what we could do is we can git switch to CircuitPython v1.2, which should be the same. Minus our, let's check out. So that the checkout just removed that change that I'd made. And now I'm going to rebase, or let's see, tag. And tag should show a 5.1.2 here. Yeah, there's a 5.1.2. So we can do a git rebase I v5.1.2. And that's annoying. That's not what we want. Does that do it? Ah, no. Git rebase abort. Once again, deep dive turns into git foo. Okay, so that didn't work. But git rebase has a I want interactive, but I think I want to do onto and then give it the root as well. So because it was trying to rebase all of those other expressive commits, and I don't want those. So I'm going to do rebase -I onto v5.1.2, and then I'm going to give it the base of expressive release v5.1. That's what I want. I want the five commits that are CircuitPython related. And now if we do git log, we can see that we have that. And as we go down, we hit the tag for 5.1.2. Okay. Let's get status again. We will get submodule init recursive. So that checked out other stuff, which is probably what we want. And let's see if the build works now. Usually it's fine. Usually we do take like somewhere in the middle of those release branches, but there is, I think they do extra checking before they do a proper release. So, and we don't need the absolute latest. There's nothing there that I know of that we actually need. And if there is, it's probably a reason for them to do a 5.1.3. So this is probably, it's probably better to, because the branch is actually called 5.1.2, it's probably better to make it 5.1.2. Like actually based on that tag. Okay. So we'll try this again. It'd be nice to get all these other fixes, but we'll have to see when they're going to release them. It's probably not a good idea to control C during a rebase, but I couldn't help myself. I do like doing rebases. This is like a window setup that I've been liking for my espresso work. So the setup I have here is I do all my builds and my loading up here. And then the left-hand panel here is the serial debug output from the IDF. And the right-hand side is the CircuitPython USB serial. I do all like printf debugging on the espresso boards, so that's how I have it set up. Oh, and we're an hour and a half in the deep dive, and I mentioned I got a new laptop, and nobody's like, what laptop did you get? Although maybe you know already. Okay, great, it compiled. Okay, so let's see if this solves all our problems. Git add ESP IDF. Oh, but you know what we need to do? We need to change to the ESP IDF, and we need to git push Adafruit CircuitPython force-with-lease. Force-with-lease is a way to force, but only if your local copy of a branch matches what upstreams is. It prevents, if somebody else were to change upstream, then this wouldn't work, which is nice. Okay, so I force updated it. Git add ESP IDF. And now we want to base on the latest high-end MacBook Pro. Wrong. That is not what I got. I'm like, I was a Mac person for a while because it just worked. And then the file system is not case sensitive by default. And so I had a sparse bundle file system that was case sensitive, and then it got corrupted at some point. And that had like all my Git repos in it, which really drove me bonkers. And so like once that happened, I was kind of like, didn't necessarily want to do it anymore. So I actually didn't get a MacBook Pro. I got a frame.work laptop, which is so it's running Linux, and it's pretty much set up like this desktop is. And the reason I did that is because one, I like the setup, and two, like I have more control over the file system and things. Base on 522 exactly. Broken after. Okay. So we'll push it again, and hopefully we'll have fewer build issues. We probably will still have an issue with, like, some of the other build issues were the TFT feather, which is usually just a matter of like, was it Russian or Japanese that had the problem? Show me the web page. Good idea. Okay, frame.work. So this is the 16, so this is not one I got. And I don't know if they're actually shipping it yet. But some of the framework developers have actually tried running CircuitPython on like the keyboard for this new one, which I'm kind of like, should I have waited and got the new one? But it's also a bigger one. This is their 16-inch, and they're working on this fancy like modular keyboard sort of system. So this is the newer one. I got the Ryzen 740 13-inch, which is over there. It's smaller than my 15-inch MacBook Pro that I was coming from. But yeah, I'm pretty happy with it. I was just like web browsing with it, and it's like quite quick. Like I really like the latest AMD chips are really great. And these are like super upgradable and repairable, which is like, that's kind of one of their sticks. So here's like, if you had bought a previous one, you could buy a main board to upgrade the one that you had already bought, which is really cool. So like for 450 or for 700, you can get a new one and replace it. There's a guide for it. And you can buy the individual parts and all that. So it's quite neat. What you did. Yeah, so I got a framework. Framework 13-inch Ryzen running Linux. Oh, you didn't want to spend $5,000 on the Mac. I bet Adafruit would have been happy to do that, but like I said, I got kind of burned by the Mac, and I've been like, I do have like a bit of a like political activism streak in me, and Right to Repair is definitely part of that. So frameworks, like they're like they started with Intels. They have like 3 generations Intels, and the AMD, this was their first AMD one, and they've been around long enough that I'm comfortable. It was like $1,500 or something. Not too bad. It's definitely, oh, the audio. That's what I noticed. Like the sound, nowhere near as good as my MacBook Pro. But like, do you care how good your speakers sound on your laptop? Maybe. But I don't use the audio on it that much. Yeah, and then Dexter points out Sonoma. Sonoma, the latest Mac OS, has been having trouble with CircuitPython devices, which is unfortunate. Okay, 4752 with Japanese. So let's just see how far our build is. 11 successful, 60 in progress. It goes quite quick. DCD says, I remember paying more for my Gateway DX266. Yeah. I mean, microcontrollers are great. I wonder how, like, I've always had my eye on the STM32G0s or the G4s. I wonder how available they are now. Oh, you know what? I want to look at DigiKey. Because the access line has too little RAM. The performance line would be better. I think, I think the G0s actually have more RAM. G0. I love these charts. These charts are great. Okay, so they only have up to 128 as well. I don't think that's true. I think that this is out of date. I thought they had a high RAM parts in this family. 144. So a little more. I was looking at, the reason the G0s had caught my eye was because of, they come in really small packages. So like thinking if we ever redid like the Gemma or the Trinket, you'd be able to fit these in there. This graphic is old. Hey, look at that part availability. In stock, exclude, and RAM 17, including the 32 LQFP. So this is like, oh yeah, like $6. $5 in singles, but let's just see. QFN. Program memory size, we want that one. $3. Like, that's pretty expensive. That's like, if you wanted to run CircuitPython on it, that's the one you'd want to pick. Kfocus has a nice Linux laptop. Yeah, and I've always followed, what is the other company that is in Colorado? I think they're in Colorado, that make the desktops too, including like the cases. I forget what they're called. I want to like this series, but $3 at quantity is a lot, when an RB2040 is like 50 cents at quantity. And this is still an M0. It's a single core M0 with less flash than an RB2040. Like, RB2040 is quite nice. Not that small though. Okay, so are we just waiting for this to run? 70 successful. Wonder if we're... All the feathers built. Nice. Okay, this looks really good. We had one other one, I think, further down that broke. Okay, this should be good. All right, we have like 25 minutes left. Do folks have any? Yeah, I did mean less RAM. You're right. I did mean less RAM. That's true. And the nice thing, those G0s are really, they're single power source, or like, so you just need like a capacitor next to it. Like, it's a single capacitor. It's a lot less like supporting circuitry as well. Okay, so we have like 20 minutes. Anything that people want to talk about? The only other thing I have is that I could switch to, so what is going on here is I was like doing some internal reworking, with the hope that SD cards could be used in web workflow. So I'm like in the middle of that, but I also don't really feel like moving my brain into that. I could do forum support. I was like 20 minutes before the stream, I was like, oh, I didn't go through my email. So we could do forum support as well. Actually, yeah, I think that's kind of where I'm at. Unless, obviously, I'll take requests as well. Okay. Have you seen this extension called vimium? So if I hit F, it labels all the different links. And then you can type to press them. Nice. I2S with the quality board. Shouldn't you open the ticket to update 5.3 before launch? I don't think so, because the bug I was seeing was introduced after 5.1.2. So by being on 5.1.2, we should be okay. And that does include the like BLE support as well. So it's not critical that we do. I don't think it's critical. All right, RGB mixed images. I'm using an LCD screen with a Raspberry Pi, I assume Pico. Then I'll superimposing them. So please help me. So the way that I approach forum support is I ask myself, am I the only one that can answer this? Because Adafruit also pays people to do technical support on the forum. And it's actually also not clear that this person is using any Adafruit hardware. And generally, we prioritize supporting folks that have purchased actual Adafruit hardware. So this is generic. A lot of people can answer this. I don't need to do it, so I'm just going to return to the forum. Struggling using a PyPico on a Windows computer, which I don't have a background. So I don't know this either. So this is probably just going to be me saying like, oh, I don't know. I just mark it all as, I look at everything, but I don't always reply. And for example, here, like Dan already replied. Oh, vimium. It's like Vim plus Chromium. That's what this one is. How did you describe the vimium extension? Okay, so think Vim as in the editor. So you hit F, and then it labels all the links with different letter combinations. So I'm pointing to my screen and you can't see it actually. So if I wanted to click this here, I type the letter L. If I want to click this, I type S and then L. And I can also do Shift H will send me back as well. It's just like, and you can use it on any page, but for some reason I generally just use it for forum support. It's just a really easy way to like click through everything. I have an 11.9 display I want to use with the RP2040 DAVI. It's a wave share. Again, this falls in my bucket of like, you should really ask wave share. So again, I'll leave it to somebody else or it'll just go unanswered. CircuitPy, really impressed. Great. I've got a C3 board from Seed, so not Adafruit hardware, connected to something from the PyHot. I've got it connected. It runs without error, but the display doesn't work. Like, it's okay if somebody else helped them, but like as somebody who's paid by Adafruit, it's like, I kind of question, like, I mean, obviously I'm biased because I get paid by Adafruit, but like, you went to the Adafruit technical support forum and asked for help with no Adafruit hardware. I don't even know if we carry any of it. Like, I get it that it's micropython or the CircuitPython, but like, we don't actually support everyone that uses CircuitPython. We support the people that buy from Adafruit. Anyway, hopefully this kind of like helps. We try to walk that line of like, we're happy to have other stuff supported in CircuitPython, but we're not necessarily the folks that are gonna do the work for that. I've been using the Max 31855, which I don't know, with a PIC and C. I don't know anything about that either. Mouse move, only 100 hertz. This is in the weeds, which is cool. But I don't know this either. Please help me, hardware masters. I just want to achieve 500 hertz or 1000 hertz HID mouse. I don't know. I can't help you. Then again, your screen's only updating at like 120 tops, so like I don't really know why it really matters. Somebody's saying thank you to me, which is great. So you can also do down and up for D and U for up and down. That's why I'm making it scroll. Carter. So this is how you, if you do have bad hardware from Adafruit, you'll go to the tech forum. They'll say replace it. You email support linking to this, and then support will hook you up. Last one. It's about motor, so I probably won't know either. Phase enable interface that requires a single PWM signal and a direction signal. I don't know. They don't really pay me to do forum support, so I don't feel obligated to like answer everybody. So that is done. I do have other tabs open here, but I can do that later. Any other final questions? Otherwise, we could wrap up early as well. It's getting darker and darker here. Let's see, can I think of anything else? I could show off my laptop. Or I could do a box unboxing. You know the boxes that I have up here where you can't see anymore? Hello, these boxes. I have more of these to unbox and fold. This is my ESP32S3 box. Hi, Oku. I have unexpected maker boards in here. Kfocus. Find your model. Let's take a look. Let's pull it up. Copy link. These are custom sized boxes designed to fit in IKEA bookshelves. Kind of like pizza boxes. Ooh, I do like KDE. M2 or an all ally. Oh, interesting. They have small things as well. Display. Interesting. These are all Intel CPUs. Yeah, I really like these more recent AMDs are great. Have a great weekend, Jeff. Wonder if there are others watching that are further north. Oh, perfect. Okay. Todd has a question. Any good resources for debugging CircuitPython with the debugger? Does debugging the SAMD21 with GDB still largely apply? It does. It's definitely out of date, but that is generally my approach with the debugger. It doesn't really cover expressive because that's extensive and that's kind of weird, but anything that's ARM can pretty much fall under this out-of-date guide. It is still pretty much how I do it. And I think I mentioned to you, Todd, but the best place to break when you're debugging a safe mode issue, like you are, is there's a reset into safe mode function call. And so the debugger will catch the backtrace that caused that to be called, but that's before the reset happens. So what that function will do is it will set some memory that lasts over a reset and then it resets. So the debugger is the way to do it because that function, if you stop it before it resets, then you have all the state that got you there. So you can do a backtrace usually. You can do a backtrace and see exactly like, okay, which function called reset into safe mode and why. And I'll do the full backtrace for you usually, unless the stack's corrupted, and then that's a little bit trickier. But yeah, when debugging a safe mode, that's the way to go. And in fact, on Espressif, I've actually there's a function you can call in the IDF that gives you a backtrace. I've added it to that function before for that same reason. And you can also, like, in the Espressif side, you could just put a loop that never returns so that you don't restart as well. Other tips about debugging. The RP2040 is a little tricky because it's dual core. generally you just want to break in core 0, which is where CircuitPython runs. There are a few times where you want to, like when I was doing the DVI stuff, I was actually looking at core 1. But generally core 0 is the way to go. I don't know. So if you're debugging USB, you probably, well, the Beagle is kind of expensive, but the Beagle is also great if you're debugging USB. So there's a Beagle 12, which is like a USB sniffer. It's maybe not called Beagle 12. Yeah, it's like 500 bucks. Yeah, 495. Like it's not cheap. But it is, if you're having USB problems, being able to see every individual USB packet is really helpful. Oh, but tiny USB. So there is a way to enable tiny USB debug logging, which is probably what you want. Oh, you got a Beagle. Well, that's helpful too. But there is also tiny USB debugging, and it's in supervisor, shared, USB, TUSB config has a, this is the thing that tiny USB does, but if you can set CircuitPy debug tiny USB, and it looks like it needs console UART as well. But then that will spit out all of the tiny USB debugging stuff, which is a lot. And actually, it takes multiple numbers. So higher numbers will spit out more stuff as well. If you're crashing during enumeration. But I thought you were having problems with the MIDI library. If it's crashing, then yeah, you want to be at this level. But if it's just the MIDI library, the host MIDI library that's having problems, then it may just be a Python side descriptor thing. But yeah, a Beagle's nice as well. Already doing console UART? Yes, and I had forgotten that tiny USB debugging you can enable as well. What else was I gonna say? Oh, there's also, and I don't think I've added, this guide is so old I haven't put it in here. But there's also a really helpful project. B. Nahill is the person that did it, called PyCortex mdebug. This is great. It integrates, so GDB has Python embedded in it now, and you can write extensions to GDB in Python. So what this one is doing is this one allows you to load an SVD file. Problem is plugging CircuitPython device into USB host CircuitPython causes the device to panic. Yeah, I think I saw that. I've seen that before. I don't know why. Causes the device to panic. Yeah, I think I did see that. You can make sure you file an issue about it as well, because TAC, who does tiny USB and is funded by Adafruit, and I think other people give him money too, but it's mostly Adafruit as far as I know. He can look into it too. Yeah, so SVD, system view descriptions. This is basically a description of all the different peripherals, where they are in the memory map, and the registers and the bits, the bit level stuff. So if you are in GDB land, this is great. This is really great for browsing all of the different registers. So I recommend PyCortex mdebug as well. I'll just post that there because I imagine David's going to snag it. But yeah, CircuitPython dev is a great place to get help. I know you know this, Todd, but for other folks as well. SVD files are kind of like a, I believe it does. SVD files are kind of like an ARM thing. So like not only does ARM provide the cores, but they provide like a lot of the tooling to assemble ARM system on chips, because they also do like, you know, ARM also provides UART stuff and the memory buses and stuff. They provide that as well. So generally anything with an ARM core is gonna, you can find the SVD files for it. In fact, they have a link. Find SimSys vendor. Oh, I don't see them there. I'm sure that exists. It might be in here. Issues. This implies that there is an SVD file. Where exactly I find it is the question. See, like this says SVD file is missing. It's got to be in there. Why haven't I found it? Why didn't it find the file name? I think I can find it on my own. Source. RP2040 hardware registers SVD. Here we go. So this is what the file looks like. It has like a top level device, a description, CPU information. So what revision is it? Because you can actually configure it as well. And then you can see peripherals. So like XIP control is the name, and then here's where the address box starts, and this is the interrupts it has. And then here's a register, here's what the bits are, here's the description of it. It's very similar to like the tables that you will find in a data sheet, but it's like more like machine readable because it's XML. So yeah, it should work with RP2040 as well. It's a big long file. 46,000 lines. They auto-generate it. So I assume that they have a system that generates this and also generates the data sheet. Give you that as well. Okay, I think that's it. It's just about 4 o'clock and I've run out of topics that don't involve me getting my brain back into some space. Actually, you know what? Before we do that, let's look. It's a green check mark. Great. So moving back to 5.12 seems to have fixed the builds. Lucky us. And yeah, 470 files. I had to disable this new optimization to make it fit, but that was it. All right, so hopefully over the weekend or early next week, we'll be first based on IDF 5.12, which brings the new BLE stuff, although we won't use it yet. But yeah, thanks, Dexter. Thank you all. Let me wrap up. And actually, I'll switch the camera too. So this has been another deep dive with Scott. I'm going to be kind of like maybe not, maybe yes, maybe not, week to week, especially through the holidays, and dependent on how my mom's doing. So he'll kind of, I'll communicate with Tim, and he'll plan on doing it probably if I'm not able to. Yeah, so thanks. If you want to support me, you can do that by going to adafruit.com and purchasing hardware there. They pay me to work on this stuff and pay me to stream, so it's been great. If you want to join the Discord server, which is a chat that lasts all the time, not just during the streams, and that's the middle thing right here when I got the side right, you can go to the URL adafru.it/discord. I'm on there during the week usually when I'm working. Take the weekends off. And thanks again to DCD, who's in the Discord chat, for taking time codes. He usually does. I'm assuming he did today. Thanks. Yeah, thanks for all the support. We're gonna have some really cool stuff coming out. More next year. I don't know anything like immediately, but Lamore's working her way through the respin list, the stuff that she's got to redo, and it's going to be exciting when she gets past that, and hopefully have more stuff early next year. Check out CircuitPython 9. It's got lots of great changes in it, yeah, thank you all for your support, and it's wonderful to hang out and have some normalcy. So thanks again, and see you on Discord, and maybe deep diving next week. I don't know.